Welcome to AlphaNumericTricks. Today we are going to see some of the problems under Z transform. Before going to see how to do these problems, we will do some series expansions. That is, we know the well-known series which is very helpful in doing problems. I'll list out the formulas, just formulas, you remember this, okay? When mod x is less than 1, these are the series we are using in Z transform. 1 by 1 minus 1 by x is equal to 1 plus x squared plus etc. This will go up to infinity. Okay. And then next formula is 1 by 1 plus x is equal to, or you can write this to be 1 plus x whole power minus 1, which is equal to 1 minus x plus x squared minus x cube plus etc. Here plus is plus and here minus is there, alternate plus minus, and here only one minus alone is there, then you have all the terms are plus. And next one, 1 by 1 minus x the whole square. This formula can be written as 1 minus x whole power minus 2. This is here both the terms are minus, so all the terms are plus in the expansion. 1 plus 2x plus 3x squared plus 4x cube plus etc. up to infinity. This is the formula you have to remember. This will be helpful when doing problems in the whole Z transform problems. And then 1 plus x the whole square, 1 by 1 plus x the whole square, or otherwise this can be written as 1 plus x whole power minus 2. This is here alternate plus minus, so in this formula you have alternate plus minus. 1 minus 2x plus 3x squared minus 4x cube plus etc. Okay, this is the formulas we frequently use. Some other formulas is also there. Next one is e power x. Expansion of e power x is 1 plus x by 1 factorial plus x squared by 2 factorial plus x cube by 3 factorial plus etc. When you remember these formulas, when you are doing problems, it will be very helpful to you. Log of 1 plus x. What is this formula? X minus x squared by 2 plus x cube by 3 minus x power 4 by 4 plus etc. Okay. And the next one, log of 1 minus x. This is the formula you have to remember. All the terms are minus here. Minus x squared by 2 minus x cube by 3 minus x power 4 by 4 minus etc. This is the formula you can remember. Or you can write this to be x plus x squared. By this way also you can remember this. This can be written as taking one minus outside, x plus x squared by 2 plus x cube by 3 plus etc. and you take that minus this side, so minus log of 1 minus x. This way also you can remember this formula. Okay, and the next one, sin x. Sin x formula is x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial plus etc. And in the same way, cos x is equal to 1 minus x squared by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial plus etc. These are the formulas you have to remember. This will be very helpful when you are doing problems under Z transform. Okay. Now we will do the first problem. Z transform of minus 1 whole power n. That is, we have to find the Z transform of this. What is this definition? Z transform of f of n. Z transform of f of n is summation n is equal to 0 to infinity f of n into z power minus n. In the place of f of n, you have minus 1 whole power minus 1. We have to do it. So n is equal to 0 to infinity minus 1 whole power minus n. Minus 1 whole power n z power minus n. Okay, this is the result we have to give it. Okay, and which is equal to, or you can write this to be, this term can be written as, you can write this to, suppose n is equal to 0, 1, 2, 3, substitute this. Substituting n is equal to 0, what happened? Minus 1 power 0, it is 1. N is equal to 0, is it power 0, 1, so you have 1. And then when n is equal to 1, minus 1 whole power 1 is minus z power minus 1. Okay, and then when n is equal to 2, minus 1 the whole square is plus z power minus 2. Minus, what about n is equal to 3, minus 1 whole power 3 minus z power minus 1, that is z power minus 3, plus etc. Alternate plus minus term you have. Okay, so which is equal to, alternate plus, that is, what is this term? Here 1 or this term can be written as 1 minus 1 by z plus 1 by z squared minus 1 by z cube plus etc. Compare this result with here, 1 minus x plus x squared minus x cube plus etc. Isn't it? In the place of x you have 1 by z. Here you comparing these two terms. In the place of x you have 1 by z. So you can write this to be 1. In the place of x you have to write 1 by x, 1 by z. 1 plus 1 by z whole power minus 1. Is that clear? Comparing this, whole power minus 1. Okay, so when you're writing this you have to compare this formula. In the place of x you have 1 by z in our problem, 1 by z in our problem. In the place of x squared, 1 by z whole squared minus all the terms are there. So 1 plus x whole power minus 1 is this expansion. So in our problem, in the place of x you have 1 by z. So we have this term taking LCM, yeah, z plus 1 divided by z whole power minus 1, or you can have z by z plus 1. This is the expansion for z transform of minus 1 whole power n, and the convergence here is mod z is always greater than 1. Okay. And then next problem, what about next problem? We have to do z transform of n. Okay, next problem is we have to find out z transform of n. Z transform of n, how we can get the z transform of n here? That is, you have a formula. Z transform of n is, you have a formula, or you can write this way. Directly also you can do it. Okay, is a transform of n, use the substitution here. Summation is a transform of n, we have to find out summation n is equal to, wait a second. Okay, so is a transform of n, we have to do it, which is equal to summation n is equal to 0 to infinity. Okay, n into in the place of n you have f of n, you have n alone. Okay, n into z power minus n. Okay, when you're substituting n is equal to 0, this term becomes 0. N is equal to 1, you have 1 into z power minus 1, plus n is equal to 2, you have a 2 into z power minus 2, plus n is equal to 3, you have a 3 into z power minus 3, plus etc. Okay, or you can write this term to be 1 by z plus 2 by z squared plus 3 by z cube plus etc. Okay, and then here we all the problems we have, that is here 1 by z is common, isn't it? So we take 1 by z outside. So 1 plus 2 by z plus 3 by z squared plus etc. Okay, this is the value. And you can have, this is of the form, look at the formula here. This is of the form 1 plus, here 1 minus x whole power minus 2 is of the form 1 plus 2x plus 3x squared, like that you have. So or you can write this to be z into 1 by z into 1 plus 2 into 1 by z plus 3 into 1 by z the whole squared plus etc. Okay, so this is of the form 1 minus x whole power minus 2. 1 minus x whole power minus 2, that is 1 plus 2x plus 3x squared plus etc. This is the form. Here in the place of x you have 1 by z is there, and in the place of x squared you have 1 by z the whole square. So you can use this formula 1 by z into 1 minus x. In the place of x you have 1 by z whole power minus 2. Okay, so you have to apply the formula correctly. 1 by z into taking LCM you have z minus 1 by z the whole power minus 2, or you can have when you're taking the reciprocal, the negative term becomes positive. So z by the z squared by z minus 1 the whole square. Is that clear? So our z get cancelled. So remaining you have z by z minus 1 the whole squared. This is the value of z transform of n. Okay, this is the value of z transform of n, and you can prove this result by another way also. We have one property. Now we studied one property, z transform of n into f of n, isn't it? Z transform of n into f of n. We studied one property. Using that property also we can prove this result. Now we try that property. Z transform of n into f of n is you have minus z into d by dz of f of z. This is the property we studied already, isn't it? Here z transform of n, we have to find out f of n is equal to 1. So we can use this to be minus z into d by dz of f of 1. Z transform of 1 we have to write it. Okay, so we have that is z transform of the function 1. We have to write like this, minus z into d by dz of, what is z transform of 1? Z by z minus 1, isn't it? Z transform of 1 is, we already proved that. Z transform, you have to remember these results. Z transform of 1 is z by z minus 1. So minus z into, you have to differentiate this with respect to z using u by v rule. So z minus 1 into, that is denominator into differentiation of numerator with respect to z. Differentiation with respect to z is 1 minus numerator into differentiation of the denominator with respect to z. Z differentiation with respect to z is 1 minus 0. So 1 alone you have, divided by denominator square. Denominator is z minus 1 the whole square. Or you have minus z into, here z minus 1 minus z divided by z minus 1 the whole square. Okay, is that clear? Now minus z plus z get cancelled, and minus 1 into minus z you have plus z divided by z minus 1 the whole square. This is z transform of n. This way also you can prove that. Whichever the method you can feel easy, you can use that to get the answer. This problem can be done in two ways. This is one method, and this is the another method. We are doing directly using definition. We are using this solution directly, but here we are using property. We find the z transform of n. This is two ways you can do this problem. Next one, we will find z transform of n squared. Z transform of n squared we will do now. Z transform of n squared. Okay, how will you find out z transform of n squared? You have to use the property. Okay, z transform of n squared, you have to use the property and get the value. And how will you write z transform of n? That is Z transform of n can be written as n into n, isn't it? Z transform of n can be written as n into n. N squared can be written as n into n, or you can write using the property. We just now use the property now here. Z transform of n into f of n is minus z into d by dz of f of z, isn't it? So the same property we have to use it here. In the place of f of n, you have n is there. So minus z for this is n, and for this n we are applying the formula minus z d by dz of z transform of the function here is n. Okay, so you have to apply the result of z transform of n directly and you can differentiate it, which is equal to minus z into d by dz of what is z transform of n? We just now obtained the answer. So z by z minus 1d whole square. Okay, so which is equal to minus z into, you have to differentiate this using u by v rule with respect to z. Is a denominator into differentiation of numerator with respect to z, that is z with respect to z is 1 minus numerator is z into differentiation of denominator with respect to z. Z minus 1 the whole square is 2 into z minus 1 into z minus 1 differentiation with respect to z is 1. Okay, divided by denominator squared z minus 1 whole square is there. When you're squaring the whole square, it becomes whole power 4, which is equal to minus z into, here you can take z minus 1 is common, isn't it, here in these two terms. So take z minus 1 outside. After taking z minus 1 outside, numerator you have 1 z minus 1 is taken outside. So remaining z minus 1 minus, here 1 z minus 1 is taken outside, remaining you have a 2z. Divided by z minus 1 whole power 4, and here z minus 1 and this z minus 1 get cancelled, remaining you have a 3. So which is equal to minus z into, here minus z minus 2z plus z, isn't it? So z minus 2z, it is minus z. Okay, and this minus 1 you have to write it here, divided by z minus 1d whole cube. Okay, so here you can take this minus outside. Already one minus is there, so minus minus it becomes plus, into when you're taking a minus outside, it becomes z plus 1 divided by z minus 1d whole cube, divided by z minus 1d whole cube. This is the transform of n square. These result you should be you should remember these results. Okay, when you're doing problems, we can use this results directly and get the, we proceed further. For that you need, that is, you have to remember these results. What about next problem? Our next problem is z transform of n a power n. Z transform of n a power n. We will do here z transform of n into a power n. Again you can apply the same property, that is same formula, differentiation formula you can apply. So z transform of n into a power n, f of n here is a power n. So using differentiation property, z transform of n into a power n is equal to, or you can write, if you want you write differentiation property, n into f of n is equal to minus z d by dz of f of n, f of z, or is a transform of f of n. Okay, but here is a transform of n into a power n, we have to use it. So minus z d by dz of f of n here is a power n. So is a transform of a power n, we have to use it. Or minus z into d by dz of, what is a transform of a power n? Z by z minus a. Okay, z transform of a power n is z by z minus a. These are the things you should remember, then only you can able to do it. Okay, if you forget this, just find out using a definition and you can get the answer. but it will take time. So to avoid that, you have to remember these standard not formulas. Minus z into, you have to differentiate this with respect to z. Here again, numerator also z and denominator is also having z. You have to apply u by v rule. So z minus a denominator into differentiation of z with respect to z is 1 minus numerator into differentiation of the denominator with respect to z. That is z minus a differentiation is z differentiation with respect to z is 1 minus a is constant differentiation with respect to z becomes 0. So 1 minus 0 is this and divided by z minus a the whole square. What about this term? Minus z into here z minus a minus z. Okay, isn't it? This is we became 1 and here 1 minus 0 is 1 minus z is there divided by z minus a the whole square, or minus z plus z get cancelled and here minus a into minus z is you have a z divided by z minus a the whole square. This is the z transform of n into a power n. You have to remember this result also. And next we have to prove that z transform of n into n minus 1, isn't it? How will you write z transform of n into n minus 1? You multiply this n squared minus n, isn't it? What about, you can, since z transform as a linear, so you can write this to be z transform of n squared minus z transform of n. What about z transform of n squared? We just now got the result, isn't it? Substitute here. Z transform of n squared is z into z plus 1 divided by z minus 1 the whole cube minus, what about z transform of n? Z transform of n here is z by z minus 1 the whole square. Z transform of n is z by z minus 1 the whole square. Z minus 1 the whole square. So this is the result we have. And we have to simplify this, okay. So here what is the LCM? Z minus 1 the whole cube is our LCM and this term is z minus 1 the whole cube is there. So z into z plus 1 as it is minus z into, when you're comparing this, here whole square is there but here you have a cube. So 1 is z minus 1, we have to multiply here and divide, okay. Then you have to simplify this one. Z squared, here z is taken inside, so z squared plus z, here also you have to take minus z squared plus z, minus z into minus z minus 1 it becomes plus z divided by z minus 1 the whole cube. Okay, so minus z squared plus z squared get cancelled. So final answer here is 2z divided by z minus 1 the whole cube. This is the z transform of n into n minus 1 value. This also you have to remember. That's all for this video. Remaining problems in z transforms we will do in the next class. Thanks for your time and thanks for watching. Thank you.